Welcome to our next video. Up until now, we have dealt with the Exchange Rates API, but we will switch it up a bit and consider the iTunes Search API. Here is the documentation for it. It is way longer, as this API is generally more complicated. First, we spot the base URL. According to the documentation, it is this one. Moreover, it also requires two parameters to be included in the URL: term, which is what we search for, and country, which would direct us to the country in which we want to explore the iTunes Store. Okay. We can try it out by searching for the Beatles in the US Store. We already know how to incorporate the parameters into the URL. This time, however, there is a space in one of the parameters, and this presents a problem as space is not an allowed symbol in a URL. There are a couple of conventions on how to incorporate such symbols, and the most straightforward one replaces a space with a plus sign. Let's employ it here too and see if we get a valid request. Well, it returned a 200 status code, so it worked all right. Having to worry about special symbols in the URL, though, is undesirable, as it can make the code less elegant and produce more bugs. I'm going to show you a little trick now. Instead of adding parameters manually, we can use the awesome requests library, which provides a way to automatically incorporate them into the URL. To do that, we need to pass the key value parameter pairs inside the get method to params. So we can rewrite the previous request like this: requests.get basesite, and then params equals the dictionary with the key value pairs of interest: term, the Beatles, and country, US. Note that we named the variable R instead of response. This makes it quicker to write the code and is somewhat of an unofficial naming convention among programmers. Okay, let's check the URL that was constructed through r.url. It looks exactly the same as what we constructed manually. This way of appending parameters is actually the preferred one and will ensure you won't make mistakes. So far, so good. It's high time we inspected the response of the API. We've already done that, so I'll quickly store the JSON response in a variable called info and print it with some indentation. We see the keys result count and results at first. However, the JSON is quite long, so we're unsure if more keys are hiding somewhere below. We can try to scroll, but that would be tedious, and we can miss some stuff. To check the keys, we can inspect .keys. Indeed, only those two keys are present. This is a common format for search responses. We get all objects that match our search parameters in a list associated with the key results. In addition, there's a parameter to state exactly how many results were found. Good. Turning our attention to the search results themselves, we will inspect the first one. It is a simple dictionary containing a lot of data about a musical track. Notable info may be the artist name, track price, and release date. Bear in mind that each result can be of a different type: music, music video, and so on. There are 50 such dictionaries in the list, although we may change that. We can set the results to a maximum of 200 by adding this limit parameter to our previous request, just like that. Finally, we may check the behavior of this API to invalid input parameters. Submitting request with media set to ha 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 returns a status code of 400 and an error message in the response body. Moreover, it provides a list of all other parameters that were processed with our request. Alright, that's the basics of the iTunes Store API. Now, you can practice a bit by printing out the track name of all the listed songs or extracting only their release dates, discarding the time of day. Stay tuned though, as in the next lecture, we will introduce how to tabulate this data. After that, an explanation of the common technique of pagination awaits you. Thanks for watching.